As promised, we're going to use the pattern of variables and coefficients in Pascal's triangle and then the binomial theorem using the sigma notation to expand a couple of other binomials that are to a different power and involve exponents within the binomial as well. So a couple differences here that we're going to add. So we have something to the sixth power, so let's kind of set this up with our binomial pattern here. Okay, so what we have is an a plus b to the sixth pattern. This corresponds to the row in Pascal's triangle where 6 is the second number. A is 2x to the third in this case, so there's an exponent within the binomial as well as outside the binomial. B is negative y and n is 6. Here's what our template would look like to expand a plus b to the sixth. A to the sixth plus 6a to the fifth b plus 15a to the fourth b squared plus 20a to the third b to the third plus 15a squared b to the fourth plus 6ab to the fifth plus b to the sixth. Notice the coefficients correspond to the numbers in the row of Pascal's triangle and how the exponents have decreasing values for a and increasing values for b. If I know that you're probably trying to write this in your notes, but take a minute before you go on to the rest of the video to make sure you understand where all of this came from before you go on. Okay, now I am going to do the same thing I did in the previous example. I am going to substitute 2x cubed every place there's an a and negative y every place there's a b, making sure to put both of them in parentheses. Now this takes me more than one line because I can't write this all the way across. It's too wide. Notice I have, if you look at the red lines, I have 7 terms altogether. So whenever you have something to the sixth power, you're going to end up with 7 terms. When I talk about a term is anything that's all multiplied together. In between the terms are addition or subtraction. So take a minute to look and see how I've inserted the 2x cubed and the negative y every place there's an a and b. Be very careful with your parentheses on that. The next step is to simplify each term so that at the end we're going to end up with just a coefficient, an x to some exponent, and a y to some exponent. Also notice that y is a negative. This is a negative y. So whenever it's raised to an odd power, we're going to have end up with a negative term. So this is a positive times a negative. So this is going to end up being a negative term. Negative y squared is positive, so we'll end up with a positive term here. So we'll have alternating signs on our terms. So I am going to scroll down here and show how I've begun with the first couple of terms, the first 3 terms here, how I have kind of expanded them out. So 2x cubed to the sixth is 2 to the sixth times x cubed to the sixth. Well, x cubed to the sixth is x cubed times x cubed times x cubed times x cubed 6 times. So it's going to end up being x to the 18th power. You just, when you raise a power to a power, you multiply the exponents. Here we have 6 times 2 to the fifth times x to the 3 times 5, and then times negative y. Be careful. When you simplify this, this is not minus y. This is times negative y. So the negative sign is going to end up at the beginning of the term with the coefficient, and we're just going to have an x to the 15th y at the end. 15 times 2 to the fourth times x to the 12th times y squared. This is going to be a positive y squared because it's a negative times a negative. Okay, then I'm going to go down here. Now, I didn't write out all of the terms in this middle part here like I did the first 3. So you can see 2 to the 6th is 64, x to the 18th. There's my first term. Notice the lovely colors. I really liked this, that I would use different colors for them. I thought that was a good touch. I hope you like it. This is 6 times 2 to the 5th, which turns out to be a negative 192. And then I have x to the 15th y. So notice the negative sign comes up front with the coefficient because when I multiply all these together, I get a negative number. 15 times 2 to the 16th, so that ends up being 24. I'm sorry, 2 to the 4th is 16, so 15 times 16 is 240, x to the 12th y squared. And then here we're looking at this one. This ends up being 20. Let me kind of go up a little bit. There we go. 20 times 2 to the 3rd times x to the 9th. So there's 20 times 8 is the negative 160, x to the 9th, y to the 3rd. It's negative because negative y to the 3rd is a negative number. Then we have, for the purple term, we're looking at 15, 2 squared, x to the 6th times y to the 4th, and so forth. I think you can look at the next one. I'll just talk about it briefly. 6 times 2, x to the 3rd, so 12x to the 3rd times negative y to the 5th, so that's a negative number. So it becomes negative, and then we just have negative y to the 6th, which is positive y to the 6th. So that's what your term should look like. As cumbersome as this is to do, it's still a whole lot faster than multiplying 2x minus y times itself 6 times. It's still a time saver. Okay, let's look at then applying the binomial theorem. Now, you'll be glad to know that I'm not going to use the binomial theorem to find all 7 of these terms. I'm just going to use it to find one of the terms. So let's find one of the terms with this. Okay, so here's my setup of my binomial theorem. All right, so I'm going to substitute for a plus b to the n, 2x cubed minus y to the 6th, which means every place there's an n is a 6. Every place where the a is becomes 2x cubed, and where the b is negative y. Now, I want the third term. So remember that r equals 0 is my first term, r equals 1 is my second term, and r equals 3 would be my third term. Because when we go from 0 to 6 for our term numbers, we have 7 terms. But the 7th term is r equals 6, right? The first term is r equals 0. So we're a little off. We have to be careful about that. So I'm going to substitute 2 for r and then simplify. All right, so here's my work. All right, so I have 6 select 2. So look at the blue part first. 6 select 2, 2x cubed to the 6 minus 2, which is 2x cubed to the 4th, negative y squared. I need to figure out what 6 select 2 is. So this is where I'm going to go back to how do you evaluate that binomial coefficient. Now I could go to the 6th row of my Pascal's triangle to figure out what this number is. That's one option. I could go down, I could look at my Pascal's triangle like I did before. All right, so I can go up to here and I say, oh, the third term has a coefficient of 15, so I can just use Pascal's triangle to figure that out. That would be one option. However, we're going to see the next example after this one. That's not as good of an option, so I also want to show you our factorial approach. So we say 6 factorial in the numerator, 6 minus 2, or 4 factorial in the denominator, and also 2 factorial in the denominator. What I want you to notice, and this is always going to work, be true with the binomial theorem, is this 4 and this 2. Oops. So we have a 6 here, 6 minus 2 and 2. It's the same thing as here as a 6 factorial, a 6 minus 2 factorial, and a 2 factorial. Those are always going to be the same. So you're going to see this pattern, the 4 and the 2 here, the 4 and the 2 here. So then we have 6 times 5 times 4, 3, 2, 1. Okay, that's 4 factorial. We also have a 4, 3, 2, 1 in the denominator. So I'm not going to write that out because I know all the 4, 3, 2, 1 is just going to divide out. Then I have 30 over 2, which is 15. And then I go ahead and evaluate the rest of it exactly the way I did before with the pattern, 15 times 2 to the 4th, x to the 12th, y squared. There's my term. Let's look at this, the binomial theorem, with one more example. Okay, let's look at x plus 5y squared to the 12th. And I want to find the 5th term. I could write a bunch of rows of Pascal's triangle, and that would actually be a way to do it, but you'll see that it's probably not a good way to do it when you see the size of the number that we end up getting for that coefficient. So I would suggest doing it the way that I'm going to show you here. X plus 5y squared to the 12th. Notice x is my a, 5y squared is b, and n is 12. So this is a polynomial that is going to end up with 13 terms. And I'm not going to have you do all 13 terms. I'm just going to have you find the 5th term, which is when r is 4. So I'm going to substitute 4 for r. Okay, so look at the blue side first over here, and kind of how I set this up. So we have 12, select 4, x to the 12 minus 4, 5y squared to the 4th. Scroll up so you can see that that's I'm just substituting for every place there's an r in the actual formula. Notice the summation part, that means add up all the terms, and I'm only looking at one term, so I don't put the sigma part in when I'm actually evaluating the terms. So this would be x to the 8. 5y squared to the 4th would be 5 to the 4th, y to the 8th. Now, how do I figure out 12, select 4? I need to pull this down a little farther so you can see. And actually, I think I'll just turn it off here. There we go. All right, so 12 in the numerator, 12 minus 4, 8, and then also 4 in the denominator, all factorial. So I have 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. But I also have an 8, 7, 6, 5, 4, 3, 2, 1 in the denominator, so I'm just going to write that as 8 factorial, and all that's gone. Then I have 4, 3, 2, 1. 4 times 3 is 12, so I can just eliminate that right away. Now I have 11 times 10 times 9 divided by 2. That's 495. There we go. 495. But don't forget there's this 5 to the 4th over here too. So 495. Now, had you done Pascal's triangle, one of the coefficients in the triangle would have been 495. So you'd end up having to do quite a lot of work to get down. This is really faster to use the formula for the binomial coefficient. So 495 times 5 to the 4th, which is 625, I believe, that ends up, there's my coefficient, x to the 8th, y to the 8th. Now before we end this video, I just want to show you some features of your calculator. Once again, of course, I'm going to have you show all this work and be able to do things by hand because that's important to me that you can do those things. But I also want you to make full use of your calculator when you take it to college and be able to use the features to help check your work and so forth. So let's see what the calculator can do with all of these concepts. So let's start with, where's the factorial button? Okay, so let's say I want to do 12 factorial. So let me open up a template here. 12 factorial. Well, if you go down to this little, there's a button over here next to the G on the keyboard, and it has the factorial symbol. So I can do 12 factorial over 8 factorial, and oops, I have the 8 factorial in the wrong spot here. I'm trying to do this on my keyboard, which is always cumbersome. 8 factorial and then 4 factorial. Okay, so there's the 495. Another thing you can do is type in NCR, NCR, because that is, remember that we had the big NCR was another way to write 12 over 8. We could write it as 12 select 8 with the NCR. Open a set of parentheses and put 12, comma 4. There's the comma below the pi button, and it does the same thing. So that also does the binomial coefficient. Also, I wanted just to show you that you can expand a binomial if you have a CAS version. If it's the CI inspired to CAS, if it's the CAS version, you can go to Menu and Algebra and Expand, and you can type in. I have to open another set of parentheses. 2x minus, I forget what the example problem was. But let me just put in, I'm not sure if this is it, but hang on, I'm going to pause. I'm looking at the example that we did prior to the last one, but when we had 2x cubed minus y to the 6th. So notice that I have within the parentheses that say expand, I have 2x cubed minus y to the 6th within that, and you push enter, and it will multiply it all out for you. Now you can't see all the terms, you'd have to up arrow and then scroll to the right to see the end terms, but it actually multiplies out the whole thing. So this is a good way to check your work if you don't want to just, you know, like multiply it by hand and then do it on, if you're not, obviously you can look at the key and check your work too, but this is a good way to check your work to make sure that you got the correct answer